Hello my dear students and welcome to chemical kinetics chapter. Okay, so students, in the earlier concept we have studied the quantitative relationship between the rate of the reaction and concentration of the reactants. There were two concepts which were explaining this quantitative relationship between the rate of a reaction and the concentration of reactant. First was the law of mass action. Okay, what is law of mass action? Or according to this, the rate of the reaction is the product of molar concentration of the reactants. This is what we have studied. So when we express the rate, it is like this. Okay, where what is the small k? It is called as a rate constant. Here now, whatever exponents that we have written or whatever powers that we have written for the concentration terms, they are same as that of your stoichiometric coefficient of the reactants in a balanced chemical reaction. Okay. So the next concept what we have studied is called as a rate law. Okay, what we know that law of mass action is a theoretical concept. Okay, and the rate law, what we know that it is experimentally observed. Okay, so according to rate law, what it says, that rate of the reaction, okay, is again a product of molar concentration of the reactant, and here the concentration terms of the reactants are again raised to some powers. Okay, but these powers or exponents may be same or may not be same as that of the stoichiometric coefficient of the reactants in the balanced chemical reaction. See, now you can clearly see the difference here. See, same reaction I have written here on both the sides. I have written the same reaction, but as per the law of mass action, rate is like this, and as per the rate law, now rate is expressed like this. So here if you see, the powers of the reactant concentration terms of the reactants is same as that of the stoichiometric coefficient, but here the powers may be same or may not be same. In this case it is not same as that of the stoichiometric coefficient. Now between these two, which is the correct method? We know that rate law is the correct method. Why rate law is the correct method? Because it is experimentally observed one. Okay, this is a theoretical. Okay, now there are so in examination they will be asking you to write the they will give an example, chemical reaction, and they will ask you to write the rate of a reaction. Then as per rate law you have to express the rate equation. Okay, as per the rate law, not as the law of mass action. Okay, now we will what is the conclusion so far from this rate law? I will tell you. See, two things here. See, there are different type of reactions I have taken. Now if you consider the second reaction, okay, here the rate is again the product of molar concentration of the reactant, but if you see or if you closely observe, then see, here the stoichiometric coefficient of chlorine is how much? It is 1, but here what is the power? It is half. So this exponent is not same as the stoichiometric coefficient of the reactant in the balanced chemical reaction. Okay, and similarly if you see here, it is what? It is the hydrolysis of ethyl acetate. Okay, now in this the rate of reaction does not depend on water. See here, rate is depending only on the concentration of the reactant. Okay, so why here the rate does not depend on the water? Because water here it is present in excess. It is present in excess. So remember, in any reaction, if reactant is present in excess amount, then rate does not depend on the concentration of that reactant. Okay, remember this. So again, they may ask you a tricky question like this. Okay, that they will give you examples like this, and they will tell you that the one of the reactant is in excess, like here water is in excess, and they will ask you to rate equation. Then remember this point, that in any reaction, if the reactant is present in excess amount, then the rate does not depend on the concentration of that reactant. Okay, so what is the overall conclusion from the rate law? See, obviously this tells us the quantitative relationship between rate and the concentration of the reactants. Okay, but if you observe closely, what it is saying, that how the rate of a reaction depends on concentration of individual reactant. I'll repeat again, this rate law tells us that how the rate of the reaction, okay, depends on the concentration of individual reactant. Now here see, it is same. In this reaction, rate of the reaction is same, means for NO2 also it is same, and for fluorine also it is same. If you look in this reaction, the rate is not same on the concentration of this and this. Okay, why? Here if you see 1 mole is there, means power is 1, but here power is half. So exponentially, so already we have discussed that rate of a reaction changes exponentially. So here rate, here the rate's exponent is also same, but here it is not same. Okay, I hope you are understanding. And here, as I have already told you that water is present in excess, so rate does not depend on the concentration of water. Now again, another example is that wherein hydrogen and bromine react to give you hydrogen bromide. Okay, here if you observe the rate, again if you see, rate depends as the rate depends on the concentration of hydrogen, it is not in the same way. See here, rate does not is not same for the concentration of bromine. It is again half here. Okay, so in this, what we can say, that the rate or the rate law tells us how the rate of the reaction depends on the concentration of individual reactants. Okay, now we have to study a concept which tells how the overall rate of a reaction depends on the concentration of reactants. So now students, as I have told that rate law tells us what? The dependence of the rate of the reaction on the concentration of individual reactant. Okay, now the next concept is order of a reaction, which is denoted by the small letter n. Okay, so what order of the reaction tells us? It denotes how overall rate of a reaction depends on the concentration of reactants. Okay, I hope you are getting the difference. Okay, next, how do we determine, or how do we come to the conclusion of order of a reaction? Okay, see here I have taken one general example, okay, wherein A moles of A and B moles of B is reacting to give C moles of C and D moles of D. Okay, now experiments I have carried out by changing the concentration of A and by changing the concentration of B, and after doing such things I have written the rate of the reaction. Okay, rate is equal to minus a dx upon dt. We know what does minus a dx upon dt means. It shows what? Instantaneous rate of the reaction. Okay, next, so rate is equal to minus a dx upon dt equals to rate constant into product of the molar concentration of the reactants, and these concentration terms are raised to some power. Okay, these are some power or exponents, and these exponent may be same or may not be same. Okay, see then here P and Q are the powers or exponents of the concentration terms. Then order of the reaction small n is equal to the sum of these powers. What is the order of the reaction? Is n is equal to the sum of the power of these sum of the powers of the concentration terms expressed in the rate law. Okay, that is what our definition says. Okay, many a times in the question paper you will find it define order of the reaction. So it is very simple. Order of the reaction is the sum of powers or exponents of the concentration terms of reactants as per the rate law or as per the rate equation. Okay, so I have given some examples here. See, here sulfuric chloride is there, that is decomposing, giving you sulfur dioxide and chlorine. So what is the rate of the reaction? I have written here the rate of the reaction. And how to determine the order of the reaction? The sum of the powers of the concentration terms of the reactant, isn't it? Here only one reactant is there and the rate is equal to, this is our equation that we are getting, and here the power is 1, so order of the reaction will be 1. Okay, next here I have taken another example wherein hydrogen is reacting with iodine and it is giving you 2 moles of hydrogen iodide. Okay, here as per the experiment I can write the rate of the reaction as rate is equal to minus dx upon dt, that equals to rate constant multiplied over the product of the molar concentration of hydrogen and iodine. Now order of the reaction n is equal to 2. How did I arrive it at 2? Here what is the power of hydrogen? It is 1. It is 1 here. And what is the power of iodine? It is 1. So n is equal to 1 plus 1. This is how I got the order as n equals to 2. Next, here another example. See, wherein hydrogen is reacting with the bromine and I am getting hydrogen bromide. Then rate is equal to, now if you see here, rate is equal to rate constant into product of molar concentration of hydrogen and bromine. Here look at the power of the bromine, it is half. Then how do you calculate the order of the reaction? It is n is equal to, what is the power of the hydrogen? It is 1 here. Okay, so 1 plus what is the power of the bromine is half. So 1 plus half is equal to 1.5. So what we can say from this discussion, that order of a reaction can be a whole number, or it can be even fractional, or it can be even 0. Okay, let us see that. See students, the order of the reaction as we know now, it can be what 0 sometimes, or it can be fractional, it can be 1, 2 or 3. Okay, now you can ask how it will be 0. That we will discuss when the examples, by taking some examples. But see, when n is equal to 0, it is called as a 0 ordered reaction, and when n is equal to 1, it is called as first order reaction, and when n is equal to 2, it is called as second order, and when n is equal to 3, it is called as third order. And when n value is in fractional, like this 1 by 2 or 3 by 2 or 5 by 2, it is called as fractional ordered reaction. Now the most important thing is, what is the significance of order of reaction? This is the very important fact. What is that? See, order of a reaction indicates how the rate of a reaction is affected by change in the concentration of the reactant. It means what? See, in case of first order reaction, we know that the rate of the reaction depends on the concentration of the reactant, isn't it? See, in first order reaction, if the concentration of the reactant is doubled, then rate also gets doubled. What I am saying now, when I in a first order reaction, if I double the concentration of the reactant, the rate also gets what? It also gets doubled. In case of second order reaction, if the concentration of the reactant is doubled, then it quadruples, or rate is increased by 4 times. The rate is increased by 4 times. Let us understand this how. See, for a first order reaction, what I can say, example I have, A is giving me product B, then rate I can give it as K into concentration of A. isn't it? Okay, so here n is equal to 1. Order of the reaction is 1 now. See, if I increase the concentration or double the concentration, then how we will write? Okay, after when concentration of A is doubled, then how do we write the rate equation? Is equal to K into this, isn't it? So when I increase the concentration of A, increase the concentration of A to double, I increase the concentration to 2 times. So this now means how we can write the rate equation like this. So it clearly indicating you what? When I doubled the concentration of reactant A, then the rate is also increasing how many times? 2 times. Now if I consider the second order reaction, say 2A is giving me B plus C. Okay, and if I write it as R is equal to K into square of A, isn't it? Now if I doubled the concentration, then so what will I write? When concentration, or in simple, when concentration is doubled, then what will write? R is equal to K into 2 times A to the power square. So it is obviously getting 4 times. It will get squared. It will get squared and multiplied by 2. It becomes 4 times. I hope this idea is clear for you people. Okay, so similarly in case of, see here in the tricky questions, what you can expect in the examinations is they will say that there is a first order reaction and they have increased the concentration by 3 times. Then what will happen to the rate of reaction? Then the rate of reaction will also be tripled. Okay, then similarly they will ask you that a second order reaction, in a second order reaction the concentration of the reactant is tripled, then what will happen to the rate of the reaction? Then you have to multiply here by 3. I hope you are getting it. So this is the significance of the order of the reaction. So it clearly tells us what? Order of a reaction clearly tells us what? How the rate of a reaction is affected by the concentration of the reactant. Okay, now we shall see some of the example for first order, second order, zero order and fractional order reactions. Students, here I have written example for some of the zero order, first order and other order reactions. Okay, here are some typical examples. Now they will, in the examination for 1 marks, they will be asking you give an example for zero order reaction or first order reaction or second order reaction, or especially they will ask you these two, that is fractional order reaction and for zero order reaction. These two are very important in the examination. For 1 marks they will be asking you give the example for fractional order reaction and for zero order reaction. Okay, here are few examples that I have listed for you people that you can copy, or in textbooks you can get it. Okay, so here you can see the best example for zero order reaction is decomposition of ammonia to give nitrogen gas and hydrogen gas. Now let me give you what is the meaning of zero order reaction. See, zero order reaction means here the rate of reaction does not depend on the concentration of the reactant. It does not depend on the concentration of the reactant. See, what will happen? See, if I take a platinum metal here, okay, and if ammonia gas is acquired on this platinum metal, then what will happen? This is slowly one by one that molecule will be starting decompose to give you nitrogen gas and hydrogen gas. Whatever may be the concentration of ammonia, however high or low it may be, but it is always what? One by one molecule will be getting decomposed. It does not depend on whether there are 10 molecules of ammonia, there are 100 molecules of ammonia, there are 500, 5000. It does not depend on the number of, or does not depend on the concentration of the ammonia molecule. It's just what, whenever the molecule comes in contact with the platinum, it will automatically get converted into, or it will get decomposed into nitrogen and hydrogen. I hope this point is clear for you people. So zero order reaction means where the rate of the reaction does not depend on the concentration of the reactant. Next, similarly, what is the meaning of first order reaction? It means that rate of the reaction depends on the concentration of the reactant. Okay, the first order reaction. Here you can see there is one molecule of hydrogen peroxide that is decomposing into giving you one molecule of water and half molecules, or we can say 1 mole of hydrogen peroxide, it will give you 1 mole of water and half mole of oxygen. Here rate of the reaction depends on the concentration of only hydrogen peroxide. So as we were earlier discussing about the significance of the order of a reaction, what we said that when we change the concentration of the reactant, rate also changes. So in the tricky question in the examination, what they will ask you is, they will say that they will say that in a first order reaction, the concentration of the reactant is doubled. What will happen to the rate of a reaction? Rate also gets doubled. Okay, and they can also ask you like this, like when the concentration of the reactant is halved, okay, what will happen to the rate of the reaction? Rate also gets half. Okay, then moving on to the second order reaction. Here there are some reaction, again just like in first order reaction. Let us discuss here what will happen to the rate of the reaction when we double the concentration or half, or when we make the concentration half. See here what will happen if I make the concentration of this doubled, then what will happen? Here we will write 2. Okay, then what will happen? The rate will increase 4 times. The rate will be increased by 4 times. For which? For second order reaction. Okay, for a second order reaction, when the concentration is doubled, the rate of the reaction becomes 4 times. I hope you are getting this point. Okay, similarly if they ask you to if they ask that in a second order reaction, if the concentration of the reactant is tripled, what will happen? Then you have to calculate, you have to write it 3 here. Okay, you are understanding it? So triple, then you will get what will happen to the rate of the reaction. Okay, or similarly they can ask you like in a second order reaction, if the concentration of the reactant is half, so divided by half and then square of that. I hope you are getting it. Okay, so these type of questions we will solve it later in the numericals, then you will get a clear idea. Okay, so these are the example for second order reaction. Okay, now this is, you can clearly understand here wherein nitric oxide reacting with ozone giving you nitrogen peroxide and oxygen. Here rate is equal to what? Order of the reaction, how you will calculate? Sum of the power of the concentration, sum of the powers of reactants as per the rate equation. So 1 plus 1 is equal to 2. And third order reaction, here also we have given some examples. So here in third order reaction, how do we calculate the order of a reaction? It is the sum of these powers of the reactants. So then we will get here 2 plus 1 is 3. Then as I have said earlier in the examination, two types of order of reactions are very important. One is fractional order, another one is zero order reaction. So these are some example for the fractional order reactions. Okay, you can copy them, you can pause the video and you can copy them, or in the textbooks you will find them. So students, in the previous class when we were discussing about the difference between the rate of a reaction and rate constant, there one of the important difference is that unit of rate of the reaction is always what? Moles per liter per second. Okay, then we had said that the unit of the rate constant depends on what? Order of the reaction. Now as we know what is the order of the reaction, let us see what will be the unit of order of the reaction. See, for the first order reaction, how we will write the rate equation? Like this. Okay, now what is the unit of rate? We know that moles per liter per second. Okay, then what is the unit of concentration here? It is moles per liter. Then what is the power? Power is 0. So when you multiply this, what you will get? You will get 0 this. So moles per liter per second is equal to K. So therefore unit of rate constant for a zero order reaction is how much? Moles per liter per second. I hope now you know how to calculate the unit of rate of unit of the rate constant. Now for the first order reaction, how it will become? See, what is the unit of rate? Moles per liter per second. Okay, what is the unit of concentration here? It is moles per liter. And what is the order? Order is 1. So if you multiply, what will get? K into, or rate constant into moles per liter. Then you have to cancel mole here, per liter. Then what is remaining? K is equal to per second. Therefore unit of the rate constant is per second. Similarly, when you go for second order reaction, same calculations are there. So what is the unit of rate constant for the second order reaction is liters per mole per second. It changes here. For the zero order reaction it is moles per liter per second. Here for second order reaction is liters per mole per second. How it comes? Here I have made the calculations. Simple calculation is there. You can understand it. Okay. Then for third order reaction, see what is the unit? Rate constant liter square per mole square per second. Okay. And how did it come? I have given you the detailed calculations, simple calculation. You can clearly understand that. Okay. Now a shortcut that you have to remember. Okay. What is that? I mean, this shortcut is very important from any competitive examination, and also whenever in board examinations they will be asking one tricky question. So there they will be asking what is the unit of rate constant for second order or zero order or for third order. Then immediately how to remember that? See, for 1 marks no need to do all these calculations, directly you have to give. Then how do we do that? This is a shortcut. Okay, that is rate constant is equals to moles per liter. What is the power? 1 minus n, then per second. What is n representing is here, where n represents the order of the reaction. This you have to remember. What is that? Moles per liter to the power 1 minus n, then per second. Okay, what is the what n indicates? N indicates the order of the reaction. You can cross check here only. See, if the order of the reaction is first order, then n is equal to 1. 1 minus 1 is 0. Then this unit becomes 0. Then what is the unit of rate constant for the first order reaction? We have calculated here, it is per second. Then here also it will come as per second. Now here for second order, n is equal to, you put 2. Okay, when n equal to 2, it becomes 1 minus 2. It will become minus 1 here. So what is the unit then? Per mole. Minus 1 will be there, right? Per mole. Minus 1 into minus 1, it will become plus 1. So here minus mole to the power minus 1 liter. Here it will come positive 1. So per second. So it will be liters per mole per second. Okay, when you put for third order reaction n is equal to 3, then what will become? 1 minus 3, it becomes minus 2. So minus 2 here. Okay, moles to the power minus 2, and minus 1 into minus 2, it will become plus 2. So the power of liter will be square, then per second. Okay, so this is a very important formula you have to remember. Then again in competitive examination they might ask you, now this is whatever examples we have discussed, this is for aqueous reaction, this is for aqueous or in liquid mixture. So sometimes they will be asking you what is the unit of rate constant when the reaction or reactants are in gaseous state. I'll repeat it again. What if the reactants are in gaseous state? are in gaseous state, then the concentration of reactants is expressed as atmosphere. Okay, then for zero order reaction, see, for zero order reaction, okay, what it is? Atmosphere per second. Okay, then first order is per second. For second order, it is per atmosphere per second. Then third order, it is atmosphere per square and per second. How did it come? See, the concentration of reactants in liquid state, it is expressed in what? Moles per liter. What it is? Moles per liter. That moles per liter only now we are expressing is at what? Atmosphere. I hope this point is clear. So if the reactants are in gaseous state, then what is the unit of a zero order reaction is atmosphere per second. Then first order it always remains as per second, and these are the unit for rate constant for second order and third order. So students, exam point of view, another question which is repeatedly asked is what is pseudo first order reaction? This question has been asked many a times. So let us see what is meant by pseudo first order reaction. Okay, here the meaning of pseudo means false. Okay, the meaning of pseudo is false or wrong. Okay, what are those? See, the meaning of this is the reactions which appear to be second order but actually first order reactions. Such reactions are called as pseudo first order reaction, or in another words, the reaction which are not truly first order but under certain conditions become first order are called as pseudo first order reactions. So, students, earlier when I was discussing how to write the order of the reaction, there I wrote one condition. What is that? In a reaction, if any one of the reactant is present in excess amount, then rate of the reaction does not depend on the concentration of that reactant. Okay, let us see some examples. Here, that is hydrolysis of ethyl acetate. Okay, see, here ethyl acetate when added into the water is present in excess amount. Okay, so whenever ethyl acetate is added into water, it will convert into acetic acid and ethanol is formed. Here the amount of water is so much that there is almost no change in the concentration of water. This you can understand. Say if I can take a beaker, okay, then if I add this acetate, if I add the acetate, ethyl acetate, if I add, see, very little ml, so suppose say 1000 ml is there, and if I add 10 ml, okay, so in 1000 ml how much of water will be converted? Only 10 ml. So it is almost what, 990 ml is still remaining, isn't it? So there is almost, I mean, compared to 1000 ml, change of 10 ml is nothing. So the change in the concentration of water is negligible. Okay, so it is like this, means whenever one reactant is present in excess, okay, then rate of the reaction does not depend on the concentration of that reactant. Okay, see here, if usually there are two reactants, means order will be 2. We have seen in already in the examples. Okay, here even though there are two reactants, but this reactant is present in excess, therefore the rate does not depend on the concentration of this. Therefore the rate depends on the concentration of only one reactant. Okay, so such reactions are called as pseudo first order reaction. Pseudo means false, wrong first order reactions we can say. Okay, another example is that inversion of cane sugar. Inversion of cane sugar means that this is sucrose, or you can say cane sugar. Again, when water is added in excess amount, or this is added into the water, again the change in the concentration of water is very less. Why? Because this is in huge amount. Okay, compared to this is in very huge amount, so the change in the concentration of water is very less. Therefore this is another example for the pseudo first order reaction. So remember students, this question has been asked for 1 marks or 2 marks. If they ask it for 2 marks, they will ask you to define pseudo first order reaction and give one example, or directly they may ask you define pseudo first order reaction or give one example for the pseudo first order reactions. Okay, so these are the two example for pseudo first order reactions. Thank you students.